universe is a mysterious and fascinating place. Every star you see have their own stories. Each nebula depicts the beauty of the universe. It inspires people endless curiosity and desire to explore. We live in such a respectable, in a fearful universe. It hides countless mysteries. When we look up at the stars, can't help but think, how big is the universe? Where are the boundaries of the universe? Where are we in the universe? And today, let's embark on a journey to explore the universe. From the end of time to the end of space. Go find those stories about the universe. To unlock the secrets behind the stars. There are countless galaxies in our universe, stars and planets, and the space is so vast that it is unimaginable. However, all of this, it didn't exist about 13.9 billion years ago. According to existing theories, our universe was born about 13.8 billion years ago. From an infinite density, at the beginning of the high temperature, the explosion was born. Then there is time. Space matter. So, we cannot travel to the birthplace of the universe. How do we know how the universe came into being? Speaking of which, I have to mention a famous astronomer. That's Edwin Hubble. Hubble is the father of galactic astronomy. In 1929, he used, located at the Mount Wilson Observatory in the United States, a 100-inch caliber reflecting telescope, spectral analysis of a large number of distant galaxies. A surprising phenomenon was discovered. That is, most galaxies have red meters. The so-called red meter phenomenon, electromagnetic radiation, due to the phenomenon that the starting wavelength becomes low. We know that sound is transmitted. If the sound source moves towards the observer will perceive the frequency of the sound going up. Conversely, if the sound is far away from the observer perceives the sound frequency as lower. This is the Doppler effect of sound. Now, the Doppler effect is not just about sound. It is suitable for almost all types of waves. And light is actually a kind of wave. It has glassy binomial properties, so light has a Doppler effect. However, the Doppler effect of light, it is expressed through color. For example, when a celestial body is moving away from us, his light waves will lengthen as he moves away. The color of the spectrum will move like the red end. If you come near us, the wavelength of the light wave will be shortened. The color of the spectrum will shift towards the blue end. At that time, Hubble has officially observed the spectra of most galaxies. The lines all move towards the red end without exception. So Hubble came to a startling conclusion. That is, the distant celestial bodies are moving away from us. And also found, the farther away the galaxy, the faster it is receding. Afterwards, Hubble came up with the famous Hubble's law. That is, the speed at which the galaxy is receding is proportional to the distance. So far, Hubble tells us, the universe is actually dynamic. It's expanding. The discovery of the expansion of the universe has made us realize the universe may have had a beginning, because since the universe has been expanding, suggesting that the universe may have been small. Suppose we reverse the expansion of the universe, which is going back in time. Then the universe may be starting from a very small point. And that's where we start. In 2013, the European Space Agency launched the Planck satellite, a detailed panorama of the cosmic microwave background radiation. Cosmic microwave background radiation. It was the first ray of light that formed after the birth of the universe. Over time, now, the wavelength of the first ray of light has been pulled into microwaves. The temperature is around 3000. At that time, Planck satellite has collected ultra-detailed, early universe, minor fluctuations in density and temperature. Astronomers have calculated from this data. The expansion rate of the universe is about 67 kilometers per second, megaparsec. The so-called megaparsec, an astronomical unit of length. It's bigger than a light year. 1 parsec is about 3.26 light years. A megaparsec is 3.26 million light years. That is to say, cosmic expansion rate about every 3.26 million light years. The speed will increase by 67 kilometers. Astronomers use the Planck satellite, measured expansion rate, the strange history that toppled our universe, dating back to 13.8 billion years ago. All matter are condensed into one, in the starting point of infinite density and high temperature. About 13.8 billion years ago, the starting point of this infinite density and high explode in a form we can't understand. In a Frank incident, that's 10 of minus 43 seconds later, the universe began to expand. At this time, the 4 basic forces are still unified, also known as the grand unified theory. After minus 35 seconds, attractive force separation, energy begins to be converted into particles, quarks. Stone 10 seconds later, neutron formation. Electroiac interaction, separated into electromagnetic force and weak interaction force. Afterwards, as the universe continued to expand and cool down, formed photons, an example dominated by electron neutrinos. 10 seconds after the Big Bang, the temperature has dropped to about 3 billion degrees. Protons and neutrons also begin to combine to form hydrogen nuclei. 380,000 years after the Big Bang, the temperature drops to 3,000 degrees. Electromagnetism binds electrons to atomic nuclei, form atoms. The universe is no longer a fog of electrons. They become transparent. Photons can finally travel through the universe, and that first light was the afterglow of the Big Bang. With the formation of a large number of atoms, attractive force begins to function and gather them into gas and nebulae. And that's when the universe began to really evolve. When the gas nebula appeared, the first stars were born. The universe is igniting everywhere. At first, the first generation of stars were massive because of the abundance of elements. The mass of most stars, even hundreds of times the mass of the Sun. But their lifespan is short. We know, as the mass of a star increases, the more intense the nuclear reaction inside. This will cause his fuel consumption to be extremely fast. Once the fuel runs out, we can't continue fusion to release energy, ultimately breaking the balance of attractive forces. A supernova eruption leads to death. Therefore, the lifespan of the first generation just a few million years or so. After the supernova, unconsumed hydrogen left in the star's outer shell and the heavy elements made by the core will be thrown into space with a violent explosion and formed a nebula light years long. Our Sun. It is the legacy of the death of this first generation of stars, born in traces. The birth of the Sun began about 4.6 billion years ago, according to astronomers, in the remains of a previous generation of stars, because one day is approaching. Shock perturbation of supernova explosions. Inside the relic cloud, an area of high density emerges. Therefore, large numbers of nebulae begin to explore high-density regions. And because agitation is conserved, the nebula is constantly spinning as it contracts, and it forms a disc-shaped structure. And this disc structure is a circular disc. And in his center, the layout also follows the beach shot collected into a high-density sphere. And this process took tens of millions of years. After tens of millions of years, temperature and pressure of high-density spheres still rising. Finally, one day, it reached more than 10 million degrees. So hydrogen is ignited. There was a thermonuclear reaction in the core. The Sun was born. After the birth of the primordial Sun, the remaining material on the periphery continues to revolve around the Sun and slowly gather in the long river of time. Gas-formed gas giants. Heavy elements form rocky planets. Our Earth was also born at this time. The Earth was just a tiny speck of dust. But the dust gathers over time. It's getting bigger. Eventually formed a huge primitive Earth. In the beginning, our planet was very active. The surface is lava. It's a hell of a world. No life. About 4.5 billion years ago, Earth's temperature starts to drop. The surface cools to a solid state. And the water resources carried by previous meteorites, and its own water vapor, also condensed into small water. Then it fell down in the form of rain. So the oceans appeared on the Earth. Emergence of the ocean. It can be said that it laid the foundation for later life. About 3.8 billion years ago, water life has emerged from Earth's underwater hot springs. These are the earliest protocells of single-celled life, and the ancestor of all life. In the days that followed, they're constantly evolving. From the very beginning, a single cell formed cells in life. About 2.5 billion years ago, the Earth experienced a major oxidation event. Cyanobacteria evolved to become the first photosynthetic device. They can harness light energy, converting carbon dioxide and water into organic matter, and release oxygen. We can say that the Sun gave life to our planet. If there is no Sun, there would be no life. Our Sun is a medium-mass yellow dwarf. It's huge. Could hold 1.3 billion planets. That's 99.86% the mass of the entire solar system. That's 330,000 times the Earth. When you step into its surface, you'll find it extremely terrifying here. Temperatures up to 5,600 degrees Celsius. And sometimes there's bursts of activity. And at his core, it's happening all the time. Harmful light fusion reaction. About 600 million tons of hydrogen fusion per second to 596 million tons of damage. 4 million tons of hydrogen converted into energy and released. And these energies, it is the light and heat we receive every day. However, the light and heat brought by the sun won't last forever. Due to the consumption of fuel, the sun will have less and less hydrogen. Calculated according to its mass, the sun will burn for about 5 billion years. That is to say, in 5 billion years, the sun will die. Scientists speculate about 4 billion years later, sun will move from the main narration stage to another stage. This phase is known as the red giant phase. During the red giant stage, the sun's core is almost depleted of hydrogen. All that's left is the bad stuff. And the C element requires higher fusion conditions. This means that, at this point, the sun can no longer continue to fuse energy. Keep balance. Therefore, this balance will be upset. Attractive forces will prevail. And the core resists its own attractive forces, will contract towards the center. Temperature and pressure rise sharply. At 100 million degrees, astral elements will trigger a new round of nuclear fusion reactions. That's how pi fuses to carbon. And as the core temperature rises, the hydrogen on the outside will expand outwards. The diameter of the sun will increase by more than 200 times. By then, our Earth, Venus, Mars will be swallowed by the expanding sun. And before that, the Earth will be baked by the heat of the sun. Liquid water evaporates completely. Even the surface will melt into a state of lava. Everything on Earth will be destroyed. If you could be on the surface of the Earth right now, you will see a huge fireball like never before rose from the east. Earth is no longer the vibrant world it used to be. It's an apocalyptic hell. But the star stage won't last long. Only about 1 billion years. After 1 billion years, with the depletion of C elements, there will be no more fusion reactions to release energy. The sun will completely disintegrate. The remaining material is thrown away, forming beautiful planetary nebulae. Finally, only a very dense white dwarf remains at the core. This is the fate of the sun. In fact, in our universe, there are many such dead stars. And depending on the quality, the manner of death also varies. If the mass is more than 8 times that of the sun, stars up to 30 times smaller, his way will die in the explosion. Such stars are more massive. They fuse the carbon until the iron stops. Then a supernova occurs. Stars like these go supernova. The quality of the core, usually 1.4 to 3.2 times the mass of the sun. The attractive force will continue to explore, and squeeze principle pushing electrons into the nucleus. Homoproton binding to neutron. This is what we call neutron nature. Shenchu Temple is 650 light-years away from us. It's such a star. It's in the constellation Orion, is a red supergiant, at least 16 times the mass of the Sun. It can hold 700 million suns. If you replace the location of the Sun and Shenchu, it will exceed the orbit of Jupiter. At this moment, Shenchu Temple is approaching the end stage of life. Astronomers predict, maybe in 100,000 years, a supernova explodes. And when he exploded, the luminosity can even exceed the full moon state. It can last for months. This means that it is still visible during the day. And then, over the course of a few years, the brightness will gradually fade. By then, Orion's left shoulder will lose one, a star that glows red, leaving only a dense neutron star. Neutron stars are actually very small in diameter, only a few dozen kilometers, but the mass per cubic centimeter can reach more than 100 million tons. And his attractive force, after the light enters his range, will break free in the form of a parabola. Its escape velocity can reach 50% of the speed of light. But neutron stars aren't the scariest thing. The most terrifying thing is a black hole. Black holes are also formed after the death of stars, when a massive star comes to an end. If the core is more than 3.2 times the mass of the Sun, that is, it exceeds the Macau-Hammer limit, then the kernel will continue to explore. Under attractive force, the neutrons will all grind into powder and gather to a point. Then a black hole will form. Black holes are arguably the most attractive force in the universe. Strong celestial body in his center is the starting point of an infinitely dense high temperature. All matter is compressed into this point. So its attractive force is stronger than any substance. Into his attractive force will be swallowed. Not even the fastest light can escape. Its escape velocity exceeds the speed of light. That's why we can't do that with the naked eye. Reasons to see black holes. So we can only pass through some rooms, discovering the existence of black holes. Like when a black hole is eating matter, will form a high-speed suction disk around, discover his existence, or observe the unusual motions of stars, because the attractive force of a black hole affects the motion of stars. Suppose we see a star rotating around an invisible source of attractive force. Can guess. This invisible attractive force is the black hole. Except for black holes that we can't see with the naked eye. In fact, there are some things we can't see, such as dark matter and dark energy. According to modern cosmological models, in our universe, matter that can actually be seen, only a tiny part of the universe, only about 4.9%. The rest is 26.8% dark matter and 68.3% dark energy. Dark matter is a completely invisible substance. It doesn't absorb reflected or radiated light, not even found in the electromagnetic spectrum. So we cannot perceive the existence of dark matter. So since dark matter cannot be perceived, and how do we know that it exists? In fact, dark matter is not the same as visible matter. Interaction, but it has an attractive force. Well known. The attractive force is the weakest of the four fundamental forces, but he's still a great wall force, can act on infinite sources. The size of its attractive force is proportional to the product of mass, inversely proportional to the square of the distance. By the law of universal gravitation, we can know the laws of motion of celestial bodies. For example, when a planet orbits a star. If the planet gets closer to the star, the faster the revolution. The further you go, the slower you go. This is the attractive force due to the square of the distance, inversely proportional. However, in the 1930s, astronomers, when studying the velocities of stars in the Milky Way, a surprising discovery: the velocity of stars outside the Milky Way, but faster than theory predicted. That is to say, according to existing theories, the attractive force at the galactic center doesn't bind the stars outside. It's falling apart. Fly away. So scientists speculate. There may be an invisible substance in the Milky Way galaxy, additional attractive force. This additional attractive force, it is provided by matter. Therefore, we can find out in some indirect ways. His method is the attractive force lens effect. Attractive force lens, it's Einstein in general relativity, a phenomenon mentioned when a beam of light from a distant galaxy, it bends when it passes through heavy materials to form one or more similar. Convergence effect of convex lens. This is the attractive force lens. Astronomers observe the universe through the Hubble telescope. Many galaxies were officially discovered. Even galaxy clusters are abruptly distorted. Its environment can reach millions of light years. And this huge lens, it cannot be formed from visible matter. Therefore, the existence of dark matter is indirectly proved. Except for dark matter. And then there's dark energy. In fact, dark energy is more mysterious than dark matter. We don't know anything about him yet. According to current observations, our universe is actually accelerating its expansion. So what energy? The universe's expansion has been accelerating. Scientists speculate the main culprit behind the expansion of the universe may be dark energy. Energy is a negative pressure energy, the opposite force equivalent to the attractive force. It acts as a repulsive force in the universe. If there is no existence of energy, the universe may only contract under attractive forces. All galaxies are getting closer. Eventually, matter gathers to a point, become the very beginning of the universe. Therefore, the universe must be maintained by energy. Otherwise, everything will cease to exist.
很大。
But dark energy is accelerating the expansion of the universe. It's not a good thing either. A scientist has come up with a theory. If the universe keeps expanding, then dark energy density may increase with space. In other words, the galaxies are moving further and further away from us. Final star, planet, even atoms get shredded as they expand. The theory is the end of the universe, the Big Rip. However, the above is just a guess. And will the universe ever end? We'll never know. In fact, about the universe, there are still many questions we don't know. For example, the most curious thing is how big the universe is. According to the current human understanding of the universe, we got it. The Earth is located in the inner solar system, the third planet. Close to the Sun are Mercury and Venus. And from the outside of the Earth, Mars in turn, Jupiter, 5-star, Uranus, and Neptune. Neptune is the farthest from Earth, reached 4.5 billion kilometers. This distance is even one trip at the speed of light. It also takes for hours and 15 minutes. Continue outward is a dense hollow disk of celestial bodies. Its width is about 30 astronomical units. It's called the Kuiper belt. After leaving the Kuiper belt is a spherical cloud that surrounds the entire solar system. It's called the Oort cloud. This is considered the edge of the solar system, at least about a light year from the Sun. However, just this light year, it is a chasm that human beings cannot cross in their lifetime. The farthest man-made probe currently flown by humans, it's Voyager 1. He's traveling at 17 kilometers per second, flying in the solar system for more than 40 years. And only 23 billion kilometers, equivalent to more than 20 light stones, and fly out of the Oort cloud at least tens of thousands of years. At this point, we think the solar system is big enough. But in front of the vastness of the universe, solar system, it's just a speck of dust in the Milky Way. Milky Way, it's a giant block of stars. There are at least 200 billion stars. Its diameter reaches about 160,000 light years, and all the stars are orbiting. Galactic center rotation, including our Sun. Our Sun is far from the Milky Way. The heart is about 26,000 light years, at 230 kilometers per second all the time. Around the silver core. It takes about 8 days to move an astronomical unit, 1,400 years, moving a light year, about 220 million years, able to orbit the center of the Milky Way once. In our opinion, the Milky Way is so massive. But let's keep looking ahead. We'll find the Milky Way. In fact, it is only located in a slightly larger group. This collective is the local group of galaxies. There are about 50 galaxies in the local group. It's about 10 million light years across. And there are even larger structures on top of the local group. This larger structure is called the Virgo Supercluster. Virgo Supercluster, a region about 110 million light years in diameter. About 10 billion of them are local groups like ours. However, this is not the greatest Virgo Supercluster. There is still a larger structure on it. That's the Laniakea Supercluster and the Pisces-Ceti Supercluster complex. Then to the observable diameter of the universe. observable diameter of the universe. It's what we can see, but not the true size of the universe. Due to the limitations of the speed of light, that light hasn't reached Earth yet. So we can't spy 93 billion light years away. This allows us to, we'll never know how big the universe is. So, that's the size of the observable universe. Do you know how many galaxies it contains? How many galaxies are there in the observable universe? In fact, we don't know for sure. It can only be estimated by observation. And this is also thanks to the Hubble telescope. This photograph is taken between September 2003 and January 2004 with the Hubble Space Telescope. Sky-seeking camera for a tiny region in the universe, obtained by taking a long exposure shot. It is located in the direction of Centaurus in the southern sky. The Hubble telescope lasted 113 days. After taking about 800 photos, merged to get this amazing deep space photo. It's called the Hubble ultrasound field. The Hubble ultrasound field only covers the entire sky, 12.7 millionths of an area. But it contains nearly 10,000 galaxies. The most distant and oldest galaxy in the universe. The farthest reaches more than 13 billion light years. Thereafter, astronomers based on the Hubble ultrasound field, shooting smaller sky areas. And after a cumulative exposure of nearly 2 million seconds, captured a more detailed deep space photograph. Hubble Extreme Deep. He reveals more distant and fragile galaxies. It still contains tens of thousands of galaxies. Through the Hubble telescope, analysis of deep space photos taken, scientists estimate that if you photograph all areas of the sky, then within the observable universe, there are at least 2 trillion more galaxies. You can imagine, there are so many galaxies out there in the universe. Looking back at the scale of the entire sheer number of galaxies, and this is what makes us think how insignificant humans are in the universe. From the Earth to the Sun, to the Milky Way, finally to the edge of the observable universe. Expansion at every step are beyond our imagination. And the Earth, just a faint blue dot in the solar system. The solar system is just a speck of dust in the Milky Way. The Milky Way is only in the universe, one of trillions of galaxies. However, even on the large scales of the universe, the Earth seems insignificant. It is this small piece of land that gave birth to us. It brought us dreams and hope. And it has also inspired humans to explore the unknown, the courage and determination to pursue the mysteries of the universe. In this journey through the vast universe, our story ends here. However, with humans, in fact, the exploration of the universe has only just begun.